Hello guys, good evening. So in this video we are going to see the 5T OTA, and we are going to see the what is the input common mode range and the output common mode range of the 5T OTA. So our topic will be this is 5 transistor OTA. So let me draw the 5T OTA, and then we will going to see the input and output common mode range. So I am using PMOS as a active load. Okay, and NMOS as a input differential pair. Okay, and for current biasing I am using this bias. This is V bias. This is VCM and VCM. I am applying both input to same voltage, that is common mode voltage. Now let me write the name of the device. This is the M1, M2, this is the M3, and this is the M4, and we are taking the output from this drain. This is the output we are taking, and this is the VDD, and other one is ground, or we can say the VSS. So let us see the input common mode range. Okay, so as we know, when we apply the same voltage to both the terminal, whatever the current that is flowing through this current will be divided into two part. Okay, and here it will be flow I naught by 2, and here it will be flow I naught by 2, right? So the input common mode range means when we increase the voltage here, okay, at the input, when we increase the voltage at the input, or we decrease the voltage at input, okay, how the transistor will be behave. Okay, so we want the all the transistor is in saturation region for this variation of the common mode voltage. So what with the maximum common mode voltage such that our all transistor will be in saturation region, and what is the minimum common mode voltage such that our all transistor will be in saturation region, that is the upper and the lower limit of the input voltage. So first we will see the input common mode range. Okay, and this we call it ICMR minus. So here uh, suppose I am increasing the voltage here. I am increasing the voltage here. Okay, then sorry, I am we are looking for ICMR minus, so we have to decrease the input voltage. So let me do that. So when I am decreasing the voltage here, okay, when I am decreasing the voltage here, then what will happen? Since since this two voltage is the same, as we are decreasing the VCM, we are decreasing the voltage at both the input. So current division will be equally half and half in both these two um, uh, in these two wire. So when we decrease this input voltage, okay, and we want this current I naught by 2 as a fix, so this means our VGS will be fixed. This means our this VGS will be fixed. So when we increase the voltage here and we want VGS fixed, then this means the voltage here should be decreased. The voltage here should be decreased. Let's suppose this is the X node. So if if we decrease VCM, okay, if we decrease VCM, okay, to flow the same current I naught by 2, our Vx should also decrease such that our Vgs will be constant. So what will be happen? So when Vx will decreases, there imply the VDS of M5, okay, this is the M5 transistor, the VDS of M5 will decrease. So when this VDS will reach to the VD set, okay, at that point this M5 will be in saturation region, okay, and if the VDS decrease, if the VDS of M5 decrease, then VD set, then it will be go to the in linear region. So this input voltage, this ICMR minus input common voltage negative, that is limited by this M5, okay, this is limited by M5 transistor. So what will be the ICMR minus? That is the lowest input voltage that we can apply to the input so that all the transistor will be in saturation. So that will be the how much we can write here. uh, VGS of transistor M1 at current I naught by 2, okay, plus VD set of transistor M5 at I naught. So this will be the our minimum input voltage that we can apply at the gate of the input differential pair. So ICMR minus will be VGS of M1 at current VGS of this at current I naught by 2 plus this Vx minimum, and Vx minimum is nothing but the VD set of M3 at VD set of M5 at I naught. Okay, now let's see the what is the maximum voltage that we can apply. Okay, so let me again draw this. Let me again draw this 5T OTA. So this is nothing but the V bias, and this is VCM, and this is the VCM, and since this is a current mirror, we have to connect like this, and this is the VDD. Here we are taking the output. So what is the maximum voltage that we can apply at this VCM such that our all transistor will be in saturation? So that we call ICMR plus. So when we increase this voltage, what happen? When we increase this voltage, the voltage when we increase the voltage at the gate, the voltage at the drain will be decreased, since we are getting that 180-degree phase shift between gate and the drain. And because of that, this VDS of this M1, VDS of this M1, this is the M1, this is M2, this is M3, and this is M4, and this is M5. So what will happen? The VDS of M1 will decreases, and such that this M1 will be go to the edge of saturation region. So we can say that ICMR plus is limited by transistor M1. Okay, so as we know that to keep the M1 in the saturation region, our VGD should be less than VTH. Okay, then VG should be less than VD plus VTH. Okay, correct. Hmm. So what will be the VD? What will be the voltage here? We can see what is the voltage here. The voltage here is nothing but the VD of this M1. So voltage here is nothing but the VDD minus VSG of this transistor M3. So what is the VD? VD is nothing but the VDD minus VSG of transistor M3 at current I naught by 2. So what will be the VG maximum that we can apply? This is nothing but the VDD minus VSG of M3 at I naught by 2, okay, plus VTH. So our ICMR plus the maximum voltage that we can apply at the input such that all the transistor will be in saturation is nothing but the VDD minus VSG of M3 at I naught by 2 plus VTH. Now let's see the mm, output command mode range, that what voltage we can apply at the output so that our device will be in saturation region. Okay, we will copy this to the next page. Okay, let me draw the missing thing. Okay, let me select the pen. This will be nothing but the VDD. Okay, and let me erase this. Okay, let me erase this. So correct. Now let's see. This is the VCM. Now let's see what is the output voltage. Common mode range means so how much the output voltage we will increase or decrease so that our all transistor will be in saturation. So first let's see how much we can increase this voltage, so that we call the OCMR plus output command range maximum. Okay, so when we are increasing this V out, so what will happen when V out will be increased, then this VDS is increasing, so this will not affect. When we increase our output voltage, then VDS of this is decreasing, VDS of this is decreasing, or we can say VDS or VSD is decreasing. So this transistor will be go to the out of saturation. Okay, so we can say that OCMR plus is limited by transistor M4. Okay, so what is the maximum output voltage that we can apply? OCMR plus will be nothing but the VDD minus VD sat of M4 at I naught by 2. So this will be the maximum voltage. This is the I naught by 2. So this is the maximum voltage that we can apply such that our transistor will be in saturation region. So OCMR is nothing but the VDD minus VD sat of this transistor M4 at current I naught by 2. Now let's see what is the OCMR minus. So when we want to decrease this voltage, then what will happen? We will see. So now let's see the OCMR minus. So when we decrease this voltage, then what will happen? This VDS of this will be affected. Then we can see the OCMR minus is limited by transistor M2, and OCMR minus is nothing but the VD sat of this transistor M2 at current I naught by 2. So this is our negative voltage, that minimum voltage that we can apply it at the output. So from here we have seen the ranges of the input and range of the output voltage. So let me go through this again. Let me tell you. So input command mode range. So nothing. Input command mode range is nothing but the. So we can see from here the minimum voltage that we can apply at the input is nothing but the VGS of M1 at current I naught by 2 and plus VT set of this transistor. So this and this VGS and this will limit the ICMR minus, and ICMR plus will be like VDD minus VSG of this transistor plus VTH. Okay, and in same way we can see the output common mode range and the uh, OCMR plus and OCMR minus. Okay, so in next video we are going to see the op-amp operation. Okay, thank you so much. If you have any doubt, we can write in comment section so that we can have a discussion on that. Okay, thank you.